So we are first given this problem, this amplifier, where we have B in. Therefore, we know that the voltage here is going to be equal to B in as well. And we can apply very quick B in minus 0 divided by R1 to find this current, which is going to be equal but opposite to the current flowing this way here, because here there is no current. Therefore, once we get the current flowing here, we can very quick calculate the B out by the following: B in, which is this voltage, minus the voltage drop across this resistor, is going to be B out. So we do B out is equal to B in minus the current, this is current, that is defined here, times R2, where we end up getting B out is equal to B in times 1 plus R2 divided by R1. B in the gain, 1 plus R2 divided by R1. I'm just gonna show very quick my circuit for problem number 2. I didn't have any red wire left.
So this is a code that I'm gonna be using in order to display my analog reading. This is my display for the processing. Here you can see that all the values mirror together, all the voltage reading mirror together, the B minus, B in, and the B out. However, when I go lower to 1.9 approximately, the B minus and B out does not follow the B in. This is due to the saturation on the ohms. And yes, but between 1.9 and 5, all the values are the same, and this is due to the fact that the gain for the system in this case is 1.
Exercise number 3. Here you can see how I use a voltage divider in order to generate my artificial ground here and wire that up. And also my B in is connected to a 1K resistor, which is at the same time in series with a 10K resistor, making a gain of 10, minus 10 for this, because it's a inverting amplifier.
Now taking a look at the processing graph. So I display 4 variables: B minus, B in, B out, B and B plus. So I start from on the virtual ground, which is 2.5, and I'm gonna start moving very slowly. As you can see, as I start slowly moving my B in, I see a greater change and in a positive direction of my B out. This is because this is an inverting.
And now when B out is at platinum, there is a bigger difference between the B in and the B minus, since the voltage across R1 is greater, while our V out remains constant.
So moving to the circuit for the last exercise, know that I have to use a 5.1 K resistor instead of the 4.7 because I didn't have one of 5.7 at the time. So I hope that's okay. I connected from my B in, my resistor, and my capacitor right there, and this is my circuit.
Now moving to problem exercise number 5, we are given this amplifier where we have an R1 here, where we have a capacitor instead of a resistor. We know that there is no current flowing here, then the current here is going to be equal to the current here flowing through the capacitor, and the voltage at this point is going to be 0. So we can calculate the current, which is just going to be B in minus 0 divided by R1 that we calculate here, and therefore this current is going to equal to the current flowing through the capacitor, and we can calculate B out, which is going to equal to just the current times the inductance of the capacitor, yes. So we end up having B out is equal to this.
So finally, this is my graph for exercise number 5. So you can see how the yellow, which is my B plus, is constantly 0. This is because this is connected. The B plus is connected to the ground directly. And now we are going to start moving the potentiometer, as you see. As I move a little bit down the B in, the capacitor start getting fully charged. And when I start getting, as soon as I approach to the minus 1.5. Now, as soon as I start increasing the B and I approach to 2, the B out, this is because the capacitor start discharging.